Hello, I'm going to be going over some of the exercises from Algebra 2, Lesson 5.3. The first one that was asked about was question number 3. Write an equation for each transformation of the parent function y equals x squared. So that's telling us that every one of these is a U-shaped graph. The original parent function for a U-shaped graph is always going to be at the origin. So we have, this point here, our 0, 0 point, and we're talking about how far each of these graphs have moved from that starting point. So all of our equations are going to be in the same format. I'm going to try to write this here. Y equals x minus something, power of 2, plus something. And however far the graph moves left and right would go here. And it's backwards from what you would think. Even though we're moving to the right for positive numbers, it's going to be a minus. And then moving to the left for negative numbers, it's going to be a plus. But then on the outside, whatever's moving it up and down is going to be what you would expect it to do. So numbers moving up would have a plus, and numbers moving down would have a minus. I'm going to do problem D. I think D is the hardest one, and hopefully then seeing how to do problem D, problems A, B, and C should be a little easier. So this is going to start with y equals, in a parentheses, I have an x. Now this is either going to be a plus or a minus, depending on if the graph moved left or right. So if I said I was going to do problem D, the new vertex of problem D is right here. So from the origin, that's 1, 2, 3, 4, 5, 6 spaces to the left. So because that moves 6 spaces to the left, I know I need a plus 6. It's always the opposite, left and right here. Because it's technically negative 6 on the graph, I want a plus 6 here. And that's because we're technically doing minus a negative 6, and minus a negative changes it to a plus. I'm going to throw in a power 2. That's what gives my graph that U shape. And then at the back, I need my vertical translation. So from here, I'm counting up 1, 2 spaces to reach the new vertex of that graph. So then I will have a plus 2 at the back. So all of problems A, B, and C are going to follow the exact same format, filling in a number with a plus or minus for our left and right, filling in a number with our plus or minus for up and down. If I look at problem 4, it's actually the exact same setup, but these are all square root graphs. It tells me the parent function right here is the square root of x. So it's going to look the same, y equals, it's going to have a square root, and then inside the square root, it's going to be x plus or minus some number for our side to side, our left and right horizontal movement. We close that parentheses right at the end of the bar, and then at the back we're going to have plus or minus some number to make the graphs move up and down. Just like with the U-shaped parabola graphs, our root graphs are always starting at the origin, and then wherever that new point is, they're all kind of close to the letters, right? So like this is graph A in the green on mine. I know papers are black and white, but graph A is green on mine. Graph B looks like a purplish color. C is this red. D is this black. And E is this blue. Again, I think I'll do E just because I think that's harder than the first couple ones. But if I'm trying to move from the origin point to this new vertex point for graph E, notice that is 1 unit to the right, and then 1, 2, 3, 4 units down to that point. So I'm going to be substituting in values here and here. I'm going to start with the y equals. I'm going to throw in that square root symbol, and I'm going to open up a parentheses. Wherever I close my parentheses is where I'm going to draw my line to end. But I always throw in an x. Now because this is 1 space to the right, that will be minus 1. I'm going to close off the parentheses and then extend my line to the close parentheses, and then because it's also 4 units down, that will be a minus 4. So it's the exact same process for A through D. You might have zeros in some of these spaces. If it doesn't have any movement sideways or movement vertically, that's okay to throw in a 0, or if you want to, you can totally just leave off anywhere where there's a 0. You can straight up close the parentheses or straight up end it. Maybe I'll do one of those to tell you what I mean. Letter B. So letter B is y equals square root x, that's supposed to be a parentheses, but so letter B moved 5 units to the left, so I'm going to put a plus 5, and then I can technically call this done. It didn't move up at all. It stayed right on the axis. So I can throw on a +0 at the back if I want to, but I don't need to. Leaving off a 0 really is the same thing as writing a +0 because +0 really doesn't change anything. So write the +0 at the back or leave it off. It's the same thing. Good luck with the rest of these and let me know if you have more questions.